Hey, what's up guys, back again with another video in the C++ series. This time we're going to go over the size of, auto, and type definition keywords. Okay guys, so the last few episodes we've been going over the different types of variables and stuff like that. We have the whole number variables, and then we have the floating point number variables like the float and the double. But now I'm going to show you a few keywords which can, or they're pretty cool, you'll see in a second, but they can do pretty cool stuff. But keywords in general are just basically words that are reserved for the C++ language. So like, for example, if you were going to make, or any of these things are keywords, using, namespace, int, these are all keywords because they're specified, or they have a special meaning within the C++ language. So if you were to do something like this, int, like that, or int is equal to 5, you can't name anything int because int is specially reserved within C++ to do something special. You can't use it for anything else besides what its purpose is, which of course in this case is going to be, it's a data type, right? So we'd have to give it a custom name, right? One that's not reserved. Anyway, so that's what a keyword is basically. It's only, it's just a special word inside the language, okay? But the first thing I'm going to show you is called the size of keyword, so size of. And I think I showed you this briefly, maybe not. But what this is going to do is show you the size of different variables, so you know how much memory it takes within your computer, basically, right? So I explained before that variables and data types, they have a certain amount of memory that they can allocate. For example, the integer is going to be smaller than a long because a long is meant to hold bigger numbers, right? More digits. So the long is going to have more memory reserved within your computer, while the integer is going to have less memory, okay? But yeah, we want to use the size of keyword, or actually it's more of a method in this case, or function, to find the size of our variables, right? So let's just go ahead and show you. So let's do cout, because we're going to output the value of the size of method here, or function. So I keep saying keyword, by the way, but I mean everything's technically a keyword, but basically, well, more specifically, the size of is a function or method, as you would call it in Java, but it's a function / operator, okay, because it's going to do something special with the parameters. All right, so let me show you. Anyway, you don't have to worry about that yet, but just to be specific. But anyway, so size of, so that's going to be we're calling the function here. So inside of this, we're going to put the name of the variable that we want to get, store the or retrieve the memory from, right? So we're grabbing the amount of memory of a variable, or a data type in this case. So we can put inside of here anything like integer. Okay, now let's print that out and see what we get, okay? So we're going to run this, and let's see what it outputs. So look what do we have here. We have 4. That means that an integer is able to store 4 bytes of memory, okay? So 1 is going to be 1 byte, 2 is 2 bytes. It's stored in bytes, okay? That's what it's referencing here. So let me just add this in front of it real quick. Let's just say size of integer. Okay, and so what this is going to do is output. It's going to be more ordered. It's going to look better. So size of integer is equal to 4. There we go. Oh wait, that looks weird. Oh, we did the wrong thing. Oops. You need that, not the plus sign. So there we go. Now we get size of integer is equal to 4, because integers, of course, are the size of 4, right? So that's how you do that. All you got to do is call upon this function here. We'll learn about functions later more specifically, but this is a function. And what you do here is provide a parameter to this function, or just put something inside of it so it knows what to do, right? So in this case, we're just putting the data type integer, but we can also put a variable in there if we want to. So a variable, int, Bob is equal to 23. And now we can just put in Bob just like that. And now it's going to tell us the size of Bob, or the integer in this case. So it knows that Bob is an integer, so it's just going to go ahead and say 4 again, because of course Bob is also reserving 4 bytes of memory because it's an integer, right? So that's how that works in case you ever want to use a variable for this. But yeah, so we can also do other data types like long, stuff like that. So let's try long. Let's see what we get. And boom, we get 8, because long is able to store 8 bytes, which is significantly bigger than the integer, of course, right? We can also do boolean. We can do any data type that we want to. It's going to check the size of it and let us know. So I know it says integer still. I forgot to change it, but there, you get the point, right? So integer 1. And let me just go and copy something real quick so you can see a general idea of the different sizes. So I'll just paste this right here. Boom. Now let's run this. Oops, forgot to close the old one. There we go. So now we get size of int 4. Size of long is 4 because, we talked about how depending on the system or whatever, it's going to be the same or whatever, but don't worry about that. But anyway, so short is going to be 2, double is 8, double is pretty big if you think about it. So it's actually kind of confusing because you might think that a long is actually bigger than a double, but it's not, because if you think about it, a double is able to store more digits, but a long is able to store a higher number. So a higher number doesn't necessarily mean more memory. It's about the number of digits within the variable, okay? Hopefully that makes sense, but that's just that if you want to know what that means. But anyway, so that's going to be the size of function. I'm going to show you that. And then now I'm going to show you what's called the auto keyword. So it's kind of cool. So some languages like JavaScript, for example, have something called dynamic types, meaning that you don't have to specify integer or whatever data type you're using whenever you make a new variable. So what you can do in a dynamic type language, you can simply do variable Bob is equal to 23, right? You don't have to specify the actual variable data type. You don't have to put boolean, integer, long, anything like that. It's automatically going to figure out what the data type is going to be, and it's going to set it for you, okay? So we can actually do that within C++ itself. We don't have to specify, I put var, by the way, because that's how you do it in JavaScript. But anyway, to do that within the C++ language, instead of integer, we can specify a data type automatically. So we can do auto bob. So what it's going to do, the C++ compiler is going to look at auto bob is equal to 23. And what it's going to do is try and figure out 23. What's that going to match to? What variable data type is that going to match to, right? Obviously, this would be either a short or integer, right? So it's going to match it to its corresponding value. And then we can, it's going to basically fill it in for you, okay? It's going to do it behind the scenes. It's going to change it to integer automatically, okay? So we do auto bob if you want to, and let's try printing this out to see if it works. Sorry if I'm talking kind of fast. I get a little nervous. I don't know why, even though I have like 300 videos. But we get 23 here because, of course, auto bob is equal to 23. But so that's still an integer, as we know. We can test and see if it's an integer by what's it called? We can check the size of it, right? Because we know that integers, from what we just did a second ago, have 4 bytes of storage, right? So we can go ahead and check the size of Bob. So yep, so this is good because we're applying the knowledge that we just learned to our program. Kind of cool. So now we're gonna print out that. So now we get 4, hopefully. So we get 4, yeah, exactly, right? Because integers are 4 bytes, right? So what we know, is that behind the scenes, Bob was changed to an integer, right? Because 23 is obviously going to be an integer. But let's try doing something else. Let's try doing a boolean. So we're going to do true, and let's see what happens. So we get 1 instead. But if you remember a second ago, you might not remember, but booleans are actually able to store 1 byte of memory, okay? Because booleans aren't that big anyway, so it only needs 1 byte of storage. But yeah, this is 1 because it's a boolean, right? It automatically assumed that it was a boolean because it had the value of true, right? So yeah, auto is very basic. It's pretty simple, but it's kind of cool because sometimes you might be kind of lazy whenever you're programming. You don't want to have to type out the data type yourself. Or it's actually kind of useful because sometimes you might have giant numbers, you might have small numbers, and you're not sure which data type is going to fit inside of, in terms of numbers, because of course each number has a different, or each number data type has a different range of or size, right? So you sometimes want to allow the C++ to figure it out for you instead of, having to figure out which range it'll fall in, right? Which data type it's going to be useful for, right? So hopefully that makes sense. But you could also do bigger numbers if you want to. Of course, it might assign it to a long. Let's go ahead and check it out. Yeah, so we get 8. It's going to probably be a long. So yeah, C++ can be dynamic, and it's pretty cool. Yeah, because if you're lazy like me, then you like it too, okay? So there's one more thing I want to show you. It's called type definition. So Typedef stands for type definition, obviously. So it's used to remember a data type, okay? So for example, let's imagine this scenario. Imagine you're keeping track of the size of something, right? Like something really big, right? Wink, wink. Unsigned, we can do unsigned because it's going to be a really big number, right? It's going to be a positive number. So unsigned, long. It's going to be a really big number, obviously, as you can see here. So size is equal to, let's just generate a really big number like that. And that should fit within the bounds of this data type here. So let's try printing this out just to make sure it works, right? And we'll do cout size inline, just like that. Okay, and let's see what happens. And boom, we get the number that we just, set to the size variable. So now imagine that you want to make another one of these variables here, right? Another size for some reason, okay? So we can do unsigned long size 2. And then we can give it a new variable. What's it called? Value, right? So we can give that value here, and we can do the same thing. We could print it out if we want to. So as you can see here, every time we want to make a new size variable, we have to type out this really long data type every single time, right? So that can get kind of tedious, and if you're lazy like me, you want a better way to do it, right? So what you can do is create a type definition, which is basically going to create a variable. It's not actually a variable, but basically you can create a variable that's going to save the data type that you want to use. Okay, so let me just go ahead and show you, right? It's better to show you always, right? So we'll do type definition, so type def, and then after that we can put the data type that we want to use. So unsigned long, and now we just need to give it a name to reference it. Okay, like basically like a variable, right? So we can call it really big data type, okay, because this is obviously going to be for really big numbers, for sizes, right? So now instead of putting this instead of typing this out each and every time, we could simply do really big data type, and we can do it here too. And so the point of this really is just to make our life easier. That's the way I see it, at least. There might be another reason to use it, but that's just how I see it. And it also provides some structure, because sometimes, like in a complex application, you might be dealing with multiple types of numbers for different reasons, and sometimes this might help you remember exactly what you're dealing with here. But anyway, really the main thing for me is that it's easier to type this out and have a definition here that you can just specify every time you want a really big number, or whatever reason you're going to be using it for, okay? Or whatever situation you might use it for. You can use it for really small numbers if you want to, so like unsigned short integer. You can even do integer if you want to. So it's all your choice, really, just whatever you want to do, but it makes your life easier, okay? So yeah, that's pretty much it for this episode. I know it was pretty short, pretty simple. We just went over the size of, auto, and type definition keywords, and, you know, function, of course. But hopefully you like that. If you have any questions about what I did today, you can ask me in the comment section below. Or if you want to, you can go into our Discord link, or there's a Discord link in the description. I should probably mention that. You can go there, join our Discord. There's about 200 people inside of our Discord, and if you need help, you can ask for help there. Or if you want to hang out with us, do whatever you want to do, just join it. And also one more thing, all of the code from today's episode is going to be in the description below, so make sure you click that and bookmark it for future use. And in case you forget how to do any of this stuff, you can bookmark it and use it later, okay? So yeah, anyway, if you like this video, leave a like. If you want to see more, subscribe, and peace.